2.5 divided by 10,000 is 0.0025 square meters, and therefore we want to take and substitute those values. The force on the piston, the large piston, is 100 Newton divided by the area on the that piston is 0.0000002 is equal to the force on piston B, which we don't know, divided by 0.00025, and we can cross multiply this. We can cross multiply this, so the force on piston B is going to be given by 100 multiplied by 0.00025 divided by 0.00002. So this is going to be equal to 100 multiplied by 250, that is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Divide by 2. So this is going to give us, if we cancel, this is going to give us 1, this is 50, and in our answer we get 1, 2, 5, 0, 0.
Any classes, and they said they doubt the classes.
So we are going to get,
knowing that Leo there will be no classes. So to kapata late information.
We are going to get
class from
12,000.
One
125,000 Newton. A force of 125,000 Newton, which is several times larger than the 100 Newton that we have applied from the beginning. So we realize if you apply a smaller force, you get a very large force. And we can simply look at this video. We can look at this video and see how this video is going to help us.
Hydraulic systems are the most common application of the Pascal's principle. The hydraulic machine works on the same principle. The hydraulic machine, or more commonly known as hydraulic press, is used to lift heavy vehicles or objects with very little force. Two containers, joined at the bottom with a pipe, are taken and filled with water, and pistons are placed at each end. Now, when a force of F1 is applied at a piston A1 of lesser surface area, this is what happens. When force F1 is applied on piston of area A1, pressure developed is given by P is equal to F1 upon A1. Now, according to the Pascal's law, this pressure is transmitted equally and undiminished throughout the fluid. So, pressure exerted on piston of larger area A2 is also P, and it lifts the weight of force F2. So, pressure at A2 can be given as P is equal to F2 upon A2. Now, for both the pistons, the right-hand side of the equations can be equated, and we get F1 upon A1 is equal to F2 upon A2, which gives F1 upon F2 is equal to A1 upon A2. Now, let's see how hydraulic principle is beneficial for lifting heavy objects. So, in this case, first of all we take first the area A1 as 2 meters square, and area 2 is taken as 10 meters square, and we apply a force of 20 newtons on piston of area A1. So, if we take the value of F1 as 20, A1 as 2, A2 as 10, and we need to find out the value of F2. So, if we simplify this, we get the value of F2 as 100 newtons. Thus, larger piston will support 100 newton load, that is 5 times the load on the smaller piston. So we can multiply forces using such a device by further increasing the area of larger piston or reducing the area of smaller piston. We can multiply force. The hydraulic press does not violate the conservation of energy. See how? If, for example, the smaller piston goes downwards by 10 centimeter, the larger piston will come up by only 2 centimeters. So, force multiplied by the displacement for both the pistons are equal, which we'll see later in the concept of work.
Okay. Thank you very much. So we have seen that this system, hydraulic system, or this Pascal's principle can actually be applied in hydraulic systems to lift very heavy objects that we cannot lift on our own. We can just use it as a machine to apply a very small force to lift a very heavy force. I mean very heavy load. And therefore, it is very, very crucial in our industrial area. Thank you very much. From this, I think we are able to see the formulas, and we are able to use these formulas to solve the questions that I'm going to give you in our video. Thank you very much.